Hello students, welcome back to my channel. This is Harsh and in this video we will do exercise 2.2. Okay, so let's begin with taking the first question of this exercise, which is let a equals to 1, 2, 3 and till 14 and define a relation R from A to A R from A to A by R equals to x is related to y such that 3x minus y equals to 0, where okay, and write down its domain. Write down its domain, codomain and range. In this question we need to define a relation from set A to A by this equation 3x minus y equals to 0, and after that we need to write down domain and codomain and range of this set. Okay, let's write it down. First of all, let's take the relation which is given to us. Let me write down solution here. Solution R equals to 3x minus y equals to 0. We can write it as 3x equals to y. Now let's write down the relation in a roster form. Okay, when we put x is equal to 3, we will have x is equal to 1, we will have y is equal to 3. Let's write it down. 1 3 2 6 3 9 4 12 5 15. Okay, this much. Okay, 1 3 2 6 3 9 4 12 5 15. Now 5 15 will not come because 15 is not present in this set A set, and we need to define a relation from A set to A set only. There is no other set which is given to us. Okay, this is the relation which we'll have, and we need to write down its domain. Domain is 1 2 3 4 and till here, because 1 2 3 4 we have put the input of 1 2 3 4, and codomain is complete set. Codomain is a set which is 1 2 3 and till 14, and the range which we have is range equals to 3 6 9 and 12. Okay, this is the range which is output to us. Okay, pause the video to note it down, and now let's move to our second question, which is okay students, let's have a look at the second question, which is our second question is define a relation R on set of natural numbers by R equals to x is related to y such that y is equal to x plus 5, such that x is a natural number less than 4 and x and y belongs to natural number. Depict this relationship using the roster form and write down domain and range. Let me write down the question. Define the relation. I'm writing R for the relation on set of natural number by R equals to x is xy is related to y such that y is equal to x plus 5, and it is also given that x is natural number less than 4. X is less than 4, okay, and xy belongs to natural number, y belongs to natural number. We need to depict the relationship using roster form. Depict relationship using roster form. Okay, let's have a look at the solution. Okay, let's read out the statement once again. Define the relation R on set of natural numbers by R is equal to xy such that y is equal to x plus 5 and x is less than 4 and xy belongs to natural number. Depict this relationship using roster form. Okay, we need to depict a relationship between on the set of natural numbers, and the relation which is given to us is y is equal to x plus 5 and the value of x is given less than 4. Okay, let's write down. We'll have the relationship 1 6 2 7 and 3 8. That's it, because x is less than 4 and 4 is not included. Okay, this is the relationship, and which we have defined in the roster form. Let's write down domain and range. Of the domain is 1 2 and 3. Range is 6 7 8 6 7 8. Okay, this was the second question, and this was similar to the first question. There was no difference in the first and the second question, and the third question is also similar to the first second question, and I'm leaving the third question to you guys, and if you doubt, write me in comment section. I'll reach you there. And before that, pause the video and note it down. Okay students, let's have a look at the fourth question, which is a figure is given to us and it's said to us that show a relationship between the set P and Q. Write relationship in set builder form and raster form. And set builder form. And what else we need to find out is domain and range. Apart from that, we need to find out domain and range. Now let's see what is the figure which is given to us. The figure which is given to us is 5 6 and 7 is related to 3 4 5. This is P set and this is Q set. 3 4 and 5. 5 is related to 3, 6 related to 4 and 7 related to 5. Sorry students, if you see this arrow diagram properly, you will come to know that 5 is greater than 3 by the number 2 and 6 is greater than 4 by the number 2 and 7 is also greater than 5 by the number 2. So in set builder form we will write it as, let's have a look at the solution. In set builder form we will write it as xy is related to x such that x equals to, I'm writing as x is equal to here, x is equal to y plus 3 and x belongs to p, y belongs to q. Students, this is very important line and you need to write x belongs to p and y belongs to q, because x and y it is not written here which is x and which is y, so you need to write it down. Okay, and if you want to verify it you can verify it, and I think I have made a mistake here, because x equals to y plus 3 and y, if we put x is equal to 5 and taking y on the other side we will have y is equal to 2, which is not over here. We need to write here 2. Okay, now let's put y in the 3 in place of y. We have 3 plus 2 is equal to 5, which is equals to x. Now it is correct. Okay, now let's write it down in roster form. 5 3 6 4 and 7 5. This is the roster form. Okay, this is quite simple if you know how to write in set builder form. Okay, now let's see what is domain and what is range. Domain equals to 5 6 7 5 6 7 and range equals to 3 4 5. Okay, this is the range of the set. Okay, now let's have a look at the fifth question of this exercise, which is, but before that pause the video to note it down. Okay students, let's see what is the question. Fifth question states that let A is equal to 1 2 3 4 6 and R be the relation on A defined by AB, where A's and B belongs to A and B is exactly divisible by A. Okay, let me write down. A equals to 1 2 3 4 6 1 2 3 4 6 and R be relation on A defined by R is on A. And the relation which is provided to us is AB AB is related to A such that B belongs to A and B is exactly divisible by by what is given to us by A. Okay, write down R in roster form. Okay, write down relation in roster form. Roster form and domain and range of R. Range of R. Okay, now let's read out the statement which is given to us. A equals to 1 2 3 4 6 and R is a relation which is present on A to A, and the relation which is given to us is A B related to A and B belongs to A and B is exactly divisible by A. We need to find out relation from A set to A set such that B is exactly divisible by A. Okay, now let's see. First of all, let's write down the relation. Let me write down the solution here so that confusion becomes less. Let's write down the solution relation in roster form. 1 1 1 2 1 3 1 4 1 6, and what next? 2 2 2 4 2 6 3 3 3 6. And what next? 4 4, but not 4 6, because 4 is exactly not divisible by 6. It gives us some reminder. And last one is 6 6. Okay, now let's see what I have done here. How did I found out this relation between from A to A? We have divided the relation which was given to us is B is exactly divisible by A. B is exactly divisible by A. If you see here, I have divided 1 1 1 from 1, 2 from 1, 3 from 1, 4 from 1. And if you see these carefully, that each and every one of them is exactly divisible, and none of them give us one remainder. Okay, the remainder which it gives us is 0. Okay, and what else we need to find out is domain and range of this set. Domain is 1 2 3 4 6, because and range is also 1 2 3 4 6 is equal to 1 2 3 4 6, because 1 2 3 4 6 and 1 2 3 4 6 are present here. Okay, now none of the elements is missing in this relationship. Okay, this is important question from your exam point of view. Okay, now let's move to the sixth question, but before that, pause the video to note it down. Okay students, let's have a look at the sixth question, which is determine the domain and range of relation R defined by R is equal to x plus 5, where x belongs to 0 1 2 3 4 5. Okay, we need to find out domain and range of the relation, which is defined to us as R equals to x plus 5, such that x belongs to 0 1 2 3 4 5. 0 1 2 3 4 5. Okay, we need to depict a relationship using this x plus 5. Okay students, note that it is not given to us that we need to define a relationship from R to R or A to A set. Okay, what we have given is this set. Okay, and the x is x is belonging from this set. Okay, 0 1 2 3 4 5. Let's write down the solution in the roster form. R equals to 1 6 2 7 3 8 4 9 and 5 10, because the set is still 5. X value of x is still 5. Okay, and we have put the value of x here. When we put x value 0, we have 5, which I haven't written here, and this is our first mistake. I'm writing 0 5 here. Okay, this is our relation 0 5 1 6 2 7 3 8 4 9 and 5 10. Okay, what else we need to find out is domain and range. I think domain and range you can find it yourself, and if you have doubt, write in comment section, I'll reach there. And let's move to the seventh question. Write the relation R is equal to x is related to x is a prime number less than 10 in roster form. This was the question which I spoke right now. Right, relation R equals to x cube where x is prime number. X is prime number less than 10. Less than 10. I'm writing the symbol for less than 10 in roster form. Roster. Okay, we need to define a relationship x to x cube such that x is prime number and less than 10 in roster form. So this is the relation which is given to us, and if we write down the solution for this set, we have r equals to, so what are the prime numbers less than 10? Is 1 a prime number or a composite number? 1 is not a prime number nor composite number, it is considered as a unique number. Okay, so never consider 1 as a prime number. The prime number always start from the 2. So what is cube of 2? The cube of 2 is 8. And what next we have? Our next prime number is 3, which cube is 9. Do we need to include 4? No, 4 is not a prime number. 4 is a composite number. That's why we are not including 4. And next we have 5, because 5 is also a prime number, and the cube of 5 is 125. We are not including 7 because we are not including 6 because 6 is also a composite number. And next we have 7 and its cube is 343. Now what next? It is also composite number, 9 is also composite number. Okay, and we have given that x is prime number less than 10. Okay, this was the relationship in roster form, and it is, if it is was also given to us, write down domain and range. You will have to write down domain equals to 2 3 5 7, because 2 3 5 are the input, 2 3 5 7 are the input which we have given, and range equals to 8 9, not 9 here. The cube of 3 is 27, but 9 is the square, that's why we have to write down 27. 1 2 5 3 4 3. Students, get your results verified before you move to the next question, because sometimes you make mistakes knowingly or unknowingly. Okay, that's why it is very important to verify the questions. Now let's move to the 8th question, but before that, pause the video to note it down. Okay students, let's see what is question number 8. 8th question states that let a equals to x y z and b equals to 1 2 and find the number of relations from a to b. We need to find out number of relations. In this question we need to find out number of relations, and we have given that a set equals to x y z and b equals to 1 2. Let's move to the solution. Students, did you remember that I told you a formula in the intro of this exercise, which was 2 to the power pq, to find out the number of formulas? Okay, where p is the number of elements belonging in the a set and the q is the number of elements belonging in the b set. Okay, it is number of relations. And 2 to the power, we have 3 into 2 to the power 6, which is 64. Okay, these are the total number of relations from a to b. Okay, now let's see our last question of this exercise, which is let r be the relation on z defined by r equals to ab. B belongs to z, a minus b is integer, and find the domain and range of r. Okay, since let's write down let r equals to, let r be the relationship. Okay, be the relation on z defined by r equals to ab, such that a b belongs to integer and a minus b is integer. A minus b is integer. Find out domain and range of R. Domain and range. Okay, students, this is a quite tricky questions. This is a quite tricky question, and in this question we need to find out the relation on Z, which is defined by R equals to AB, such that A and B belongs to integer and A minus B is also integer. We need to find out domain and range. Okay, let's see what is solution. Okay, students, what are the numbers included in Z, and what is this Z? Z is the set of integer. I'm writing here, this is set of integer. And what are the integers? Integers are the numbers starting from the minus infinity to 0 and till positive infinity. You can't count the total numbers of the total number of elements present in this integer set. Okay, you need to find out domain and range. This question is just given us to confuse, to make us confused, and this is also important question from exam point of view. Okay, we need to find out domain and range. Domain and range. The relation which is given to us is a minus b is integer and ab belongs to z. Students, what if you minus an integer from integer? What you will get? I think only integer. That's why domain will also be an integer and range will also be an integer. Okay, both of these will be an integer. You will not get a irrational number. Okay, don't write here irrational number or any other thing, because these are foolish things which you write here if you don't get the question. Students, what the heck you have is read out the statement very carefully and see what the relation which is given to us, and make a visual representation of the relation which is given to you, and move to the rest part of the question which is given to you. This was a quite tricky question, and many of times it is asked in your exams, final exams. So this is very important question. I'm again marking this hash. Okay, this was the 2.2 exercise, and thank you for watching this video. And if you like the video, hit the like button and press the subscribe button. Thank you for watching the video again.